Hello and welcome. My name is Stéphane de Gérando, composer and researcher, professor of mixed and electroacoustic composition at the Conservatoire à Rayonnement Régional d'Amiens Métropole in France. Unfortunately, I am unable to be present in person today at Bard College in New York, but I am very happy to share this work with you through this video. Our paper with Gilles Barouin, Sound and Visual Objects in N Dimensions in the Labyrinth of Time, appears in the Proceedings of the 10th International Congress on Mathematics and Computation in Music, 2026, published by Springer in volume 16609. The Labyrinth of Time is a vast, polyartistic and technological project that I have been developing since 2006. It combines composition, research, and transmission with multiple examples of creative works ranging from mixed music to digital arts, including monumental projections and augmented or virtual reality productions. It is not a single work, but a living, evolving process of creation and research. Several major collaborations have shaped its development. For instance, with Jedrzejewski on homometric sets, Morogane on fiber spaces, Petri on relativistic space-time, Bigot on all-interval series, and Barrowin on hyperspherical representations and virtual reality. In collaboration with Frank Jedrzejewski, one of the important early stages of the Labyrinth of Time research project is based on the concept of homometric sets, sets of numbers sharing the same multiset of differences. For n equals 24, there exist 5,136 sets, grouped into 1,436 homometric classes. Building upon Frank Jedrzejewski's work on the enumeration of these sets, I applied this modulo 24 structure to compositional parameters in order to develop an algorithm. These values are mapped in real time onto pitch, duration, timbre, spatialization, and color, creating 6 correlated dimensions governed by a single mathematical structure. This algorithm also served as a compositional tool for writing the score. This approach notably led to the creation of homometric attractors, a work for instrumental ensemble, real-time algorithm, and 2 dancers, which received its world premiere in Paris in 2024. Then the research developed through 4 decisive collaborations. With Christophe Morogane, we formalized SVOs in fibered spaces, introducing distance formulas to measure proximity between objects within or across homometric classes. With Jérôme Petri, we established 5 relativistic artistic laws. Velocity modifies perceived duration and length. Spectral mass curves space. Simultaneity becomes observer-dependent. With Louis Bigot, we developed 2 new types of all-interval series, the STIOZ and the STISMI, leading to world premieres, Tempus Est for 2 wind orchestras, and Le Chant des STISMI for flute orchestra and real-time electronics. This brings us to the two central definitions of this paper. The polysensory hyperobject, HOPS, is defined in an n-dimensional space, where each point is a control vector of the five senses: sound, visual, tactile, olfactory, and gustatory. The sound and visual object, SVO, is a point or trajectory in this hyperspace, defined for instance by a 12-dimensional mapping: dates, duration, 4 spatial coordinates x, y, z, w, and 6 sensory parameters for sound and light. The fundamental idea marks a departure from traditional audiovisual thinking. Sound and image are not synchronized after the fact. They are the perceptual projections of a single unified mathematical object. Before settling on a definitive formalism, the development of these sound and visual objects requires carrying out highly simplified phases of cognitive, computational, and compositional experimentation. I present here 5 examples of computer programs that I created during this initial approach. The first 2 programs test our capacity to perceive more than 10 dimensions for sound, frequency, intensity, timbre, and spatialization. For the visual, hue, saturation, brightness, and spatialization, each driven by an independent rhythmic score, bringing the whole to more than 10 desynchronized dimensions. The third program, an audiovisual one, examines the perception of homometric sets and classes. The fourth experiments with a points and surfaces visualization on the web. The fifth offers a visualization of homometric attractors through the control of NURBS. My compositional and artistic vision is ultimately to be able to invent interactive virtual worlds in 4 geometric dimensions, based on the correlated or independent composition of trajectories of sound points associated with the invention of surfaces, forms. This would be a version 2 of 0 Point, the existing transposition of the labyrinth of time into virtual reality, created in collaboration with Gilles Balhois, which has already been presented as an installation at international artistic events. The transposition of SVOs into virtual reality within a 4-dimensional Euclidean space is currently being developed by Gilles. An SVO trajectory is written in R4. The 4th coordinate, W, is treated as a genuine spatial dimension, not a metaphor. Its variation produces both visible and audible consequences through projection. To display this in a VR headset, we apply a 4D to 3D perspective projection. Sound and visual parameters derive from the same 4D geometric state, guaranteeing intrinsic synchronization by construction. To test perceptual and technical aspects, a first prototype, currently under development in Unity, uses a simple hypercube as its initial structure. Users manipulate the 4th dimension in real time, observing how 4D rotations reorganize the projected sound space. The observer has a controllable perceptual mass, bending the density field and revealing hidden compositional structures. The body becomes a projection operator, a co-creator of the work. A few concluding words. The sound and visual object rests on a unified ontology. Sound and image are the perceptual projections of a single multidimensional mathematical object. The labyrinth of time is part of a research creation approach. The spectator's body becomes a projection operator, a co-creator. A topological aesthetic, multi-dimensional continuity without rupture. The labyrinth of time is not a finished object. It is a process in becoming. Before handing over to Gilles Barouin on the prospects for developing these SVOs in virtual reality, I will conclude with my latest work in progress, Homometric Sound and Visual Object 1 from the Labyrinth of Time. Here again we find an algorithmic sound and visual co-construction of the structure. 3 synchronous temporalities, V1, pitch class left, V2, set right, V3, stereo note via M, coexist on a single pulse. In parallel, each draw feeds a graphic device in which points, surfaces, and wireframes express the same homometry. A stereographic grid on S-cubed, a modulo 24 network with 24 nodes, a class polygon, a parallelepiped whose 8 vertices are the extremes of the reference frame, H1, H2, H3, M, set arcs, the comet's active trail, and the faded archives of past sets. The dimensional reduction is not a mere projection. The homometric coordinates are first placed on the 3-sphere, quaternions, transported by the set's centroid, then stereographically projected into R-cubed before being viewed on screen. A chain from R to the power of 4 to S-cubed to R-cubed to 2D. The 4th dimension does not disappear. It informs perspective depth and luminosity. HSVO1 thus turns homometry into an object, at once sonic and visual, whose form emerges from the passage from the 4th dimension into perceptible space, woven from lines and memories.